Alright, this lesson is on describing scatter plot patterns. How might you describe the pattern of the data points on this graph? Take a look at it. Are they linear, clustered, or might you say scattered? Well, they're not linear because none of them are really in a line. They're not connected to any one particular line. Clustered, you might see a few data points here that appear to be in small groups together, but overall we would describe this pattern of data points as scattered. So now that we've seen what that looks like, a scatter plot is a graph of data points that will show the relationship between two sets of data. And the data points are plotted as XY coordinates, where each point corresponds to the data in the table. So the time spent studying in hours, if it's 0.5 or half an hour, the grade in the test is 68. So that data point would be 0.5 on the x-axis and 68 on the y-axis. Likewise, an hour for the first data point here, you would see 1 hour on the x-axis, 1, and then you would see 85 on the y-axis, and that's where you would plot that point. So now we take a look at these points that are these data points that have been plotted from the table to the left. How would you describe the pattern of those points? Well, what you need to be thinking to yourself is, when you look at the graph, is as you're moving along the x-axis, what's happening along the y-axis? So as we look here, it appears, for the most part, that as we move up in the amount of time that we spend studying, the grade on the test does appear to increase. So overall, study time increases. As study time increases, the test grade increases. This indicates a positive linear relationship. Linear because most of the points are falling around or near or on a particular line going in the positive direction. We do have a few outliers. Those are circled in green here. So we might consider that an outlier. We would most definitely consider that one an outlier. Now take a look at this graph of data points. It's a scatter plot. And what do you see is happening here? Well, as the winning time in minutes gets lower, those are the years past from 1990. So 4 years past 1990 or 1994, it looks like there certainly was a faster time, winning time, for perhaps this was a race of sorts. And if we go to 1998, 8 years past 1990, the time has gotten even smaller, so it's faster. So that means that who's ever winning these races, the winning time, as the years go by, becoming faster and faster and faster. So overall, as the number of years past 1990 increases along the x-axis, the winning time on the y-axis decreases. This indicates a negative linear relationship. Again, linear because most of the points are falling on or very near that line. The relationships we've seen thus far are referred to as the correlation between the two data sets on the graph. Correlation is another term for relationship. So if we have a strong negative correlation, you can see in this first scatter plot here, the points are pretty close to each other, and what direction they seem to be going in. Well, as x is increasing, y is decreasing. So that is a strong negative correlation. Now when we look at this scatter plot here, it is a negative correlation because we could draw a line. It's not very straight. And the points are near the line, but they're certainly not as clustered around the line as they were in the first graph. So it is a negative correlation because as x is increasing, y is decreasing. However, it's a very weak negative correlation. Now let's look at the strong positive correlation. Similar to the strong negative correlation, the points along the line are very close to each other. They're almost directly on the line. I could draw a line. That's probably a better line right there. So let me erase this other line here. There we go. All right, so as you can see, it's a positive correlation because as x increases, y increases. It's a strong correlation because most of these points, if not all of them, are either on the line or very near that line. Now when I look at the weak positive correlation scatter plot, you can see that there is a positive relationship here. We do have a line that's going in the positive direction. X increases, y increases at the same time. But a lot of the points are, well, they're not very close to the line. They're pretty far apart. So it's more of a weak positive correlation for this one. Now what do we see here? We have a lot of data points. We're looking at the outside temperature in relation to test grades, how students do on a test. Does there seem to be a relationship? Well, if I were to draw and say this was positive, that's really not very good because as y increases, the outside temperature is certainly not increasing. These points are really scattered all over the place. It's neither a negative nor a positive relationship here. The reality is there's no relationship here. So there's no correlation between the temperature outside and test grades. In other words, the changes in one data set are not affecting the other data set. So, to summarize, we have learned that a positive correlation means that both data sets increase together. A negative correlation means that as one data set increases, the other decreases. And no correlation means that changes in one data set have no effect on the other data set. Strong correlations are indicated by the data points being relatively close along a straight line in either the positive or negative direction. Okay, well that ends this very brief video introducing how we describe patterns on a scatter plot. Enjoy the activity.